Problem 8 has Angela, Mary, and Tiff at an intersection. The intersection is it's University and 42nd Street. Mary and Tiff are stationary, but Angela decides to run across the intersection at 12 feet per second along a straight line. The roads are 50 feet wide, and Tiff is 60 feet north of the nearest corner. The question is asking, where is Angela located when she's closest to Mary, and when does she reach this spot? I drew a coordinate plane to figure out where their locations were in relationship to each other in the intersection. So I have Angela as the origin at 0, 0. I have Mary 50 feet north of her since she is at the corner of the intersection. Then I just drew all the corners of the intersection. They're 50 feet apart. And then I drew Tiffany being 60 feet north of the nearest corner, which is this one. So using that information, I can go ahead and just draw everything that we're looking for in the coordinate plane here. So what the question is asking is, at what point is Angela closest to Mary? And what we need to understand is that it's going to be this point here, which is where her path and the line perpendicular to it, or line perpendicular to her path and intersecting with Mary, meet. So what we first need to do is find the equation for the line for Angela, and then take the find the equation for the line for Mary, set them equal to each other, and we'll be able to find this point. So we went ahead, and this is m of m, which is really just like the slope of Mary, or sorry, let's ignore that. Let's go do the slope of Angela to Tiffany first. So we use delta y over delta x, and we get 110 over 50, which is 11 over 5. And we know that since this line right here is perpendicular, it's going to be just flipped and negative. So the slope of Mary's line is going to be negative 5 over 11. We need to use her slope and Mary's point in order to plug it into the point slope formula and get an equation for Mary's line. So we get y equals negative 5 over 11x plus 50. And then we just set the two equations equal to each other, find their points, solve for x to get the x coordinate, which is 18.8. Plug the x coordinate into either one of the formulas, and we'll get the y coordinate, which is 41.5. So that is that's going to be this point, which is where they're closest to each other. The next part of the question asks, when does she reach this spot? So what we need to figure out is the distance from here to here. So I use that by just cutting out a little triangle. I'm using the x coordinate as the base, the y coordinate as the height, and then the path as the distance from Angela to where she is closest to Mary. Use the Pythagorean theorem, and then plugged in Angela's rate into the distance equal to rate times time formula, and got that it takes Angela 3.8 seconds to reach the closest point of her approach at 18.8, 41.5 if Angela's starting point at t equals 0 is 0, 0.